Things we need to know. Recognizing need to know symmetry. Okay, we really do need to understand symmetry, so I'm gonna try to explain it the best I can. For instance, the human Inverse of a function. Okay, let's see finding the symmetry. This is more about procedures. And for each of the following graphs, list any symmetries and state whether the graph is a function. The way that we can determine if a graph is a function, we will run a vertical line test on the function to see if it's a function, or we'll run a vertical line test on the graph to see if it's a function. Okay, let's start with graph A. Can you tell what graph A is? I'll give you a few moments to figure out the answer. Okay, the answer to graph A is, this graph is symmetric about its axis at the line x equals 3. There are no other symmetries. However, the graph has the vertical line test, so it shows that it is a function. Now, let's move to graph F, and I will give you a few moments to see if you can figure out what graph F is. This graph of a cubic function, which you should have been able to identify offhand, is symmetric about the points -4 and -1, but not around the line. This graph does show a function. Once again, we already could tell based off of it being a cubic function, and it also passes the vertical line test. Let's go to graph G. I'll give you a few more moments to answer this one. This graph parabola is lying on the side. Its symmetry is about the line of y equals 2. It is not a function because it does not pass the vertical line test. The vertical line touches the graph or the curve twice. Finding the symmetry. Now we're dealing with more procedural, but we still need to be able to also identify it from sight as well. For each of the following graphs, list any symmetry and state whether the graph is a function. Okay, let's look at graph A. Okay, the big discussion about graph A is determining if this is a function. Now, everyone should know what the vertical line test is. And we'll run a vertical line test on each and every last one of the graphs that we'll check today. Alright, so you looked at graph A. Is it a function? Does it have symmetry? Let's check. Let's run a vertical line test on it. Okay, before we even read anything else, we can tell that it is a function. Alright, graph A. This graph is symmetric about its axis. The line x is equal to 3. There is no other symmetry. The graph shows a function. We already stated that based off of our vertical line test. Okay, let's look at another graph. Let's look at graph F. Okay, right off the bat, we should be able to tell that this is a function before we even run a vertical line test because it looks exactly like a cubic function. Okay, let's run a vertical line test on it. And let's see, what is it? Graph F. This graph, of course, is a cubic function. It's symmetric about the point -4 and -1, but not around the line. This graph does show a function. Now, let's take a good look at graph G. Okay, we can tell that graph G is laying on its side. Let's run a vertical line test to see if it's a function. And we can tell that it's not a function because the vertical line is touching the graph or touching the curve 2 times. Okay, let's check and see what it is. Let's check our work. Graph G, this parabola is laying on its side. It is symmetric about the line y, which equals 2. It is not a function. Okay, great job. Now we're dealing with another attribute of a function, which is the asymptotic behavior. Asymptotic behavior is a behavior such that x approaches infinity if x approaches the positive or negative infinity. Now it has two characteristics. One could be vertical, a vertical asymptote. Okay, now our job or our task is to find the domain of all asymptotes of the following function. Y equals x squared plus 3x plus 1 divided by 4x squared minus 2. The vertical asymptote is what we're going to look for first. And basically it comes from the zeros of the denominators. So I set the denominator equal to zeros inside. First of all, let's set it to 0. 4x squared minus 9 equals 0. The first step Okay, now we're at the relative max and relative minimum. The relative maximum is the largest y-coordinate or value a function takes over a given interval or of the curve. One of the main things you need to remember is the max occurs when the parabola is open downwards. It will be at the very top of the curve when the parabola is open downwards. The relative minimum is the smallest y-coordinate of the value a function takes over a given interval of the curve. The minimum occurs when the parabola opens upward. Once again, the minimum occurs when the parabola is open upward. And if we look at these two graphs below, we can tell that the max, we don't have one for this particular, for the quadratic, or excuse me, for the square root. We don't have a max, but we do have a minimum because it starts at the origin of 0, 0. Once again, for the absolute value, we do not have a max, but we have a min, because if we look at the lowest point, it starts at our origin 0, 0. Okay, now we're dealing with minimum and maximum. Relative maximum is the largest y-coordinate or value a function takes over a given interval of the curve. Now I want you to remember one thing. The maximum of a curve occurs when the parabola is open downward. Relative minimum is the smallest y-coordinate or value a function takes over a given interval of the curve. The minimum occurs when the parabola opens upwards. If we notice at the absolute value function or the absolute function, we have a max. We have no max because the curve is open upward. So we have a min at 0. And if we also notice the quadratic, the square root, our min, we have a min, but we do not have a max. Okay, what does absolute maximum mean? It means the highest point on the entire domain. If we look at the illustration, to the right, we can see by the arrow that it is at the very top of the parabola. Absolute minimum Okay, we came to the end of part 1 of our video. Alright, now I need you to go ahead and complete the quiz questions in the study guide. Also, complete part 2 of the video, things that you have to do at the end of class or for homework. Do not forget that you have questions in your study guide that goes with part 2, dealing with your math model questions. We're trying our best to relate functions to real life. I'll see you at the beginning of part 2. Be ready.